Welcome back, everybody. Today we are talking about magnetism and working on the introduction to magnetism. Okay, you guys probably have basic knowledge of magnets and how it works, but here we go. So magnets always have two poles, a north and a south pole. You may not think about it like this, but the Earth also, as you know, has a north and south pole, and it can be perceived as a big magnet. We'll talk a little bit more about that later, but yes, two poles, they always have a north and south pole. Opposite poles attract, same-sided poles repel, similar to what we learned about with electrical. Okay, and you're going to see a lot of similarities with electrical. So over here, opposite attract, similar poles repel. Okay. Even if you were to cut a magnet, it will still have a north and south pole. So if you see this here, if we cut it down the middle, now these two smaller pieces will still have a north and south. And if you cut it again, the smaller pieces will have a north and south. So you can't like cut one of the poles out. If you cut a magnet, it'll still have a north and a south pole. Magnetic poles and electric charges act similar in nature. All right. So similar to electric fields, magnets have a magnetic field. Magnetic fields are easier to see than electric fields, and you might have already seen them. Okay, similar to electric field lines, the magnetic field lines point outward from the North Pole and inward into the South Pole. Different from electric field lines, magnetic field lines go through the magnet and create full loops. So just want to show that here. You can see that the field lines go through the magnets. Okay, they're not just out of the magnets like over here. Okay, so from the north side, they're pointing outwards, and from the south side, they're pointing inwards. Okay, how it works. All right, moving on. A good video just to kind of show the magnetic field. Pretty simple to watch. Similar. Okay, Earth's magnetic field. Earth has a magnetic field that starts in the core and extends out into space. This magnetic field protects Earth from harmful radiation from the sun. Okay, if we didn't have it, we'd all be in big trouble. This video here kind of talks a little bit more about it, which is cool to watch. Okay, so conceptual example number 1. If I had a 1 meter long magnet and cut a 1 centimeter tip of the North Pole part of the magnet, what pole or poles would this 1 centimeter magnet have after it was cut? Okay, so I cut this 1 centimeter over here, then I have this sliver over here, and then I have another piece, this long piece over here. What would this sliver have? Would it only be a North Pole, only South Pole? Would it have both a North and a South, or nothing? We should remember that when you cut it, it's no matter where you cut it from, a magnet's always going to have a north and a south pole sides. Okay? Moving on. Which of the following combination of poles will have a repulsive force when brought near each other? North and north, north and south, south and south, north and west. What's going to happen is north and north and south and south. North and west, there's no west side pole. All right, example number 3. If a magnetic field is pointed toward a pole, which pole will be pointed towards? North, south, north and south, or west? So we should know that the answer is south. Remember, for a magnet, we had a magnet here, put this over here. This is the north side and the south side. The magnetic field is going to be pointing out of the north. Oh, oops, sorry. Pointing out of the north. And as it's traveling and going back in or whatever, it's going to be pointed in towards the south. Okay? So if a magnetic field is pointed toward a pole, which pole will it be pointed towards? The south pole. Okay? That's it with the intro to magnetism. I hope to see you guys more next time. Thanks for watching, everyone.